Good afternoon, everyone. My name is Ruchi Kushwaha, and I'm from IIT Bombay. We would be starting the event shortly. Before starting the event, I would like to mention few things. We are recording this event at our end, and due to the paucity of the time, we do not have an open Q&A session. Therefore, during the course of the event, if the participants or the audience have any question, we request you to kindly put it up in the chat box, and we would be answering your queries on our and putting up the responses to it on our Grid Integration Lab website and the LinkedIn page as well. So first, let me walk you through to the agenda item for today. I hope my screen is visible. The event will start with the opening remarks by Professor Suneet Singh, HOD, Department of Energy Science and Engineering, IIT Bombay. Then we have Professor Zakir from IIT Bombay welcoming our guests and the participants. Due to some exigency, Shri Ghanshyam Prasad, Chairperson and ex-officio Secretary to the Ministry of Power, CEA, is unable to attend the event today. But we are happy to have Shri Ashok Kumar Rajput, Member Power System, Ministry of Power, Central Electricity Authority, Government of India, for the guest address and report release. Then we have a presentation on V2X technology by Mr. Bjoern Christensen, CEO, Next Dimension USA, followed by another presentation on V2X implementation in India by Professor Zakir Rather from IIT Bombay. Later, we have very interesting panel discussion on V2G technology and its adoption with Professor Mattia Marinelli from Technical University Denmark, DTU, Mr. Bjoern Christensen, CEO, Next Dimension USA, Shri Ashok Kumar Rajput from CEA, and Mr. Ramkrishna Singh, Head of EV Charging Operation, Tata Power, as our esteemed panelist. And then the event would end with a vote of thanks. First and foremost, I would like to invite Professor Suneet Singh, HOD, Department of Energy Science and Engineering at IIT Bombay for his opening remarks. Suneet, sir.
Good afternoon, everyone. On behalf of the Department of Energy Science and Engineering and my personal behalf, I welcome you all for this event to mark the release of the report titled Implementation of Vehicle to Everything in India. Our department is in the forefront of energy research and education, and energy vehicles are definitely an important part of that. So I'm very happy to be present here today for these opening remarks. Coming back to the report, the study for this report has been conducted for past around 1.5 years, and its outcome is documented through executive summary and 2 detailed reports, which are going to be released in this event in a short while from now. So if you consider the rapid development in EV space and challenges and opportunity that this transition is bringing along, this study, which is the first of its kind in India, and is expected to generate momentum towards adoption of this emerging technology in Indian EV ecosystem. In-depth analysis and recommendations for V2X adoption in India covered by this study is expected to help key stakeholders and decision makers in effective and efficient deployment of this promising V2X technology in this country. So I wish this event all the best and thank you.
Thank you, sir, for your kind words. Moving forward, I would like to invite Professor Zakir Rather to welcome our speakers and the participants.
Thank you, Ruchi. A very good afternoon to all the participants here. Special guests, particularly Mr. Ashok Kumar Rajput from CA, Mr. Bjoern from Next Dimension, Mr. R.K. Singh from Tata Power, Professor Mattia from DTU. Thank you for taking your time from your busy schedule to join this event. And I would also like to welcome all the participants who are present here and who are going to join while we proceed with this event. I would very briefly introduce our chief guest here right now, Mr. A.K. Rajput from CA. He is a well-known face of Indian power sector. He has played key roles in various important and critical phases of the development of Indian power sector. So therefore, it will be difficult to summarize all his contributions that he has, given to the Indian power sector over the past 36 or more years in this time. So therefore, I will keep it very brief and short. He is currently member power systems at CA Ministry of Power, and he has been in different sections and heads of CA, including R&D. He has been also involved in REMCs and various developments of RE development in India, and has played key role in different dimensions in very critical pillars of Indian power sector. And he is playing a very important role in Indian EV mobility, EV charging infrastructure currently, along with his other responsibilities. And we are pleased to have him today here in this event, not only as a chief guest here, but also his very engaging involvement in this study and in preparing these reports. So therefore, without taking much of the time of the event, I would request Mr. Rajput to please make your address and thereafter declare the release of these reports and executive summary that is being prepared from this particular study. Over to you, Mr. Rajput.
Thank you, Professor Zakir. And I'm happy that we are meeting more than once. And frequently we remain on talk and the email. So we establish a perfect communication wherever required and share many ideas. So good evening to you. Good evening to all your team members and the panelists. And of course, the valuable audience. Basically, we started this journey and the new things that how we can move towards a better and the clear transportation mechanism. Just to have a curiosity and just to tell the background, we are mostly dependent on this diesel and the petrol vehicles. Those emit naturally the tailpipe emissions and are quite. One move is we already had the experiences of electrification of transmission in the transport sector, that in the fair form of the railway and the metro. But that's an entire different game and the entirely different technology which is used there. When we talk of the movement on the road through the vehicles, the electric vehicles comes to our rescue in the form that they create lesser and lesser pollution, or there is no tailpipe emission as such at the point of use. Of course, people may argue that if you are using the electricity and if that electricity is being generated out of the coal-based thermal power stations, so that pollution is becoming there and you are reducing the pollution here. Certainly, when the big thermal power station and all those things are there, the pollution can be controlled in an easier way. And rather than controlling at the number and the say millions of the locations. So that is a one common point or one common sense which I can say. So it's a need of the hour that we have to electrify our transportation. Naturally, as is applicable to every new technology, it takes time. Initially, the technology grows, the standards get developed, the infrastructure gets developed in a gradual manner, and then comes the mass scale rollout and the mass scale availability and the completion. Similar thing is happening now in the EV sector, be it the four-wheelers or be it the two-wheelers, or maybe if you find the manual rickshaws which were there, and that was, you can say, not creating any pollution as such, but was quite cumbersome to the laborers and the rickshaw pullers. And now in those places, you will find that lot many e-rickshaws have come and giving a good job and the better health conditions to the workforce. So there are different applications, different usage, different conditions, depending on the terrain and depending on the topology of that particular sector and that area. In the field of electrification, we need adequate number of charging infrastructures at suitable and safe locations. And we also need the interface between electric vehicles and the grid so that the grid remains stable and everybody, including the electric vehicle charging infrastructure, gets a quality and reliable power supply. So these are the two important considerations. So adoption of EVs is gaining away and people are tending towards that. Biggest hurdle which is coming is the parking spaces available with the vehicle owners or the users. Where to park? So we were here that how we do that, how could we promote? First of all, the requirement is that electric mobility or the EVs penetration be increased. Major requirement for EV penetration is one is the cost or the affordability. Another is how to accommodate those vehicles which are large in number already existing in the form of the diesel and petrol vehicles. And in place of those, how to accommodate the parking space for the EVs. That is one. Charging infrastructure is another. Then the time taking in the charging. Of course, the fast charging is coming to the rescue in the form of the public charging places. And in the form of the slow charging, the common mode is at the residences and in the offices or the commercial spaces. So for this, a particular study has been conducted by prestigious IIT Bombay under the guidance of, under the leadership of Professor Zakir Rather, who has been associated since long in such type of the studies and many other innovations about the power sector issues and the new challenges which the power sector is facing. Of course, when the EV will be more in the, you can say, environment or on the roads, naturally the electric load will be increasing on the infrastructure and there will be overloading, voltage and the power quality issues in general. Solution to those is also to be found and the experience will be the best guide in this particular thing. Efficiency, of course, is desirable and higher and higher efficiency need to be achieved. Sometimes what has happened and the criticism that these vehicles will also not be helpful in controlling the pollution or the emissions. It's not 100% true because more and more RE development is coming. And whatever is RE development is there, many times we have the excess power in the grid. And that excess RE power, or maybe a part of the RE power and part of the conventional power can support the charging of the vehicles. So that is the way we optimize our resources and we make a controlled check or a regulated check on the ever increasing emissions. Another issue is the noise pollution, and naturally the EVs have very little or minimal noise pollution. Of course, the batteries are cause of concern, particularly the battery life, the battery efficiency, and the overall disposal of those batteries what to be done. Technologies are evolving and those will be the helping solutions. It happens with every technology. V2G, why V2G is vehicle to grid or vehicle to say anything, vehicle to home, vehicle to some another establishment or vehicle to some emergency supply system. This technology is relatively new since the EV technology in itself is new. But this will be the model which will be the model of the future and would be quite helpful when large scale integration of the grid in the with the huge penetration of the RE comes into force. So there will develop various business models and those business models will be in different form. One may be say in the form of the peak support. One may be that in the form of say wherever the conventional, it is the time to have the conventional generation. And in place of the conventional generation, a part of it has been, say, met out with the electrical energy, which is in the form of the renewable electricity stored in the batteries and stored in the batteries of the electrical system, electric mobility system, that is discharged back to the point of utilization. So that is the model. It will fascinate the world, and new technology, new innovations, they are the key to the success. With a lot of experimentation in the lab and in the actual field, certainly we would be hoping the good results to come. But when it comes to, say, meeting the constraints of the system, like, say, peak demand, and where everything is important, so whatsoever we saved in the form of the electricity at the time where we were having the excess of RE, that will be the crucial factor, and that will be the key element or the precious element which we would be supplying to meet our need. And those needs will help the grid in collapsing and meeting the consumer needs at the time when they need it most. In this particular case, the tariff has to be in such a way that gives a win-win situation to each and every stakeholders. Since India is at an early stage of EV adoption, the outcome of this study documented over 2 reports, as has been described by the panelists in the beginning itself, who introduced this topic today. It contains the executive summary and the 2 valuable reports. These have the relevant inputs and the consultations with the stakeholders, OEMs, policy and regulatory decision makers in taking timely and effective measures for implementation of V2X in Indian EV ecosystem. So basically, this EV, which may seem to be a burden to some of the, you can say, persons analyzing the system in one perspective way or in a narrow way, it will be a boon to the system in the form that the critical need will be maintained, and whatever you are going to lose as a fuel which is quite clean and which is totally clean, that will be utilized. So it should be seen in that way, because we are putting in lot of efforts in the form of the mitigation of emissions. And as you know, if we start talking that what the emissions and what are the disadvantages of the harmful emissions, lot of burden is in the form of the health issues, productivity of the persons of any type. He may be highly educated person, or he may be a common man, he may be illiterate. Everybody gets affected. So a lot of burden on medical facilities and the pharma sector, and naturally it becomes a cyclic effect. So we have to find, as scientists and the policymakers, the way that we ease the life of the pupil, we make some positive improvements in the life of the pupil. So V2G study is one such step which has been undertaken by IIT Bombay. So it will further strengthen the outcome of the study and help us in better understanding the challenges and potential countermeasures for seamless adoption of V2G in Indian grid. So I'm hopeful the deliberations here and just before the release of the 2 prestigious reports will help in further understanding the subject to large number of participants. And in the participants, many of are my esteemed colleagues and friends, those with whom I have been associated in different form in the power sector. It will also help us in better designing the system models when we develop the electricity infrastructure as such, because electricity infrastructure is basic backbone on which the e-mobility will rest. So I think let me give chance to others also, and hope I have conveyed in brief as the keynote speaker on this particular occasion. Thank you, Professor. Thank you, participants, and thank you, panelists. Thanks. Over
Thank
to you,
you, Mr. Zakir
Zakir, sir.
Rajput. I think you have to declare the release of the reports before you
Okay.
hand over.
Okay. Sir, it's an honor to me, sir, and the whole CEA. In fact, chairperson could not join because of some reasons. So it's an honor, and it's an honor basically to our organization, sir.
Thank you, Mr. Rajput. Ruchi, you can proceed further. Over to you, Ruchi.
Thank you, sir, for your wonderful insights and the introduction to the reports. Now we will be releasing the reports. These are the two reports based on the study of the implementation of the vehicle to everything V2X in India. It is a detailed analysis for gaining an understanding of the technical know-how of the V2X has also been performed in the study, followed by a techno-economic analysis to determine viability of V2X implementation in the Indian context. The study has been bifurcated in two reports. The report 1 focuses on the fundamental of everything, the technology, enablers, and the challenges. And the report 2 focuses on the techno-economic analysis and the way forward for V2X implementation in India. The link to these reports will be shared in the chat box, and this can also be accessed from the QR code. Also, we will be putting up these reports on our Grid Integration Lab IIT Bombay website. So moving forward, I would like to invite Mr. Bjoern Christensen, CEO from Next Dimension USA, to present on the V2X technology. Mr. Bjoern.
Thank you for inviting me to do this presentation here. I'm very honored to be part of this event, and I'm going to tell you in about 10 minutes everything you want to know about vehicle to everything, or as we abbreviated V2X. What I would like to present to you is first, what is vehicle to everything, or V2X? And how does V2X fit into the bigger picture? It's not enough just to present the V2X, but it has to fit into a larger picture and have some benefits. And then lastly, what are the opportunities and the challenges for India with respect to V2X, which will serve as a segue to the subsequent presentation from Mr. Zakir. So let's just jump into it and look at how is a car charged today. Well, it's typically connected to a charging station, and energy is flowing from the charging station. That means basically from the grid through the charging station to charge a car. And that energy is going into the battery and is being used to drive the car. We often refer to this as V1G, or unidirectional charging, means energy from the grid to the EV. It's unidirectional. V2X is additionally allows for reverse power flow from the electrical vehicle. Not only can we charge, but we can also discharge from the battery. We can discharge to the grid, or we can discharge to a building or to a home. We can even discharge to another vehicle, or we can discharge to a load. I will explain this in more detail later. It's important to realize that all EVs are born bidirectional. If you accelerate, what happens is that energy is flowing from the battery to the electric motor. It has to go through an inverter to convert it from DC to AC. And when you brake, this regenerative energy is transferred from the electric motor and rectified and put back into the battery. So every car is born bidirectional with bidirectional power flow. Here it's made available also to the outside world. Now, how does V2X fit into the bigger picture? Well, India has a climate emergency, which we've seen in extremely high temperatures, about 47 degrees Celsius, and a pollution emergency, where because mainly emission of greenhouse gases from fossil fuel burning. So if you look at the biggest emitter of greenhouse gases in India, The first is electricity and heat producers, but transportation is on the third place. That means in order for us to minimize or to reduce the CO2 emission, we need to introduce renewables into the grid, and we need to electrify the transportation sector. And this will move the needle. This is very important for the world because India is the fourth largest emitter of CO2, as shown here, after China, United States, and EU. So with a lot of renewable energy into the grid, we will also get into a situation where the grid has to cope with different conditions that it is used to. The good news is that the installed capacity in the Indian grid, here shown in an IEA graph from 2020, from 2000 to 2020 is shown here, and then it's projected into the state policy scenario until 2040, where we can see there's going to be a large amount of solar and a large amount of wind, and there's also going to be some battery capacity. But with renewables, it will make the energy supply more volatile. Here shown a graph from California from a couple of days ago, where we can see the demand curve here in the black, and we can see the hour ahead forecast, which followed the demand curve pretty well. Now, we can also see that in the middle of the day, there's a lot of solar in the grid. We have a lot of solar here in California, as you do in India. And we see that the net demand here, which is shown in the blue curves, really goes down. So we can see that the very steep decline here and very steep ramp here currently is about 15 gigawatts in about 3 hours, which correspond to ramping about 15 nuclear power plants in a very short period of times. And we refer this to the dot curve, which if we transform this into 2030, we will have negative net demand, and we will need to start curtailing our renewable energy. But it does create a lot of volatility. The same graph here from wind in Denmark, not solar, but wind, here shown in the green curve over a period from September 1 to September 9 in 2018. The green curve here is accumulation of land-based wind and offshore wind. And we can see here that it's quite volatile and changes over these 8 days here. So we need a smarter grid. We need flexibility services to cope with all these renewables. We definitely need storage, and it's all about cost. It has to be affordable. Now, once we introduce electrical vehicles into the grid, we are going to be faced with a revolution or transformation that will rival that of the internet. The automobile sector will meet the electricity sector, which are two trillion-dollar industries that have been separated certainly before 2010, where there was really no connection between the electric grid and the automobile world. We can see now slowly that these two industries or sectors are colliding, and they will collide, hopefully in a nice way, to create a new industry segment, which we call vehicle grid integration, or VGI, where millions of electrical vehicles will have to work in harmony with the electric grid, known as vehicle to grid integration. We call this the Big Bang. It will have a revolutionary impact on the whole electrical grid and the automobile sector. So what is vehicle to grid integration? There's no official definition of VGI, but the term was coined in 2014 by California Energy Commission here in California. And it's separated into two sectors: unidirectional power flow, which is referred to as V1G. It contains dumb charging, typical public charging, where you just charge and you want to charge as fast as possible, or smart charging, where you delay the charging or you time the charging to take advantage of lower prices or lower CO2 or other factors. And then the other big category is bidirectional power flow, or V2X, where we can use the energy from the battery in the car to what we call vehicle to load, any load, which I'll show later. We can send it into the home. We can send it into the building if we are a small organization. And we can send it also back to the electric grid if there are good enough conditions. So we want to use our cars for that. I have to also to point out here that these V2G and V2X, there's some confusions out there with terminology. So often these two terms are used interchangeable. Now, when we introduce millions of electrical vehicles into the grid, we can actually strain the grid because the grid was not designed to support a lot of millions of vehicles, which has very large power demand and also some relatively large energy demand. But it could also help the electric grid if we make it vehicle to grid. All these million of electrical vehicles that will be introduced into the grid. And I'm talking about vehicles here. We should maybe mention that there are a number of other distributed energy resources, like heat pumps and solar PV. They will revolutionary the impact on the electric grid, especially the distribution grid, where they will become a load and maybe a problem if we only have a unidirectional power flow. And they can actually help the grid if we have a bidirectional power flow. The help could come in form of balancing and providing a contingency flexibility services to the transmission grid. This is mostly balancing is mostly an energy service, and the contingency services is mostly a power service. Or it could help the distribution grid with power factors, congestion, voltage, and reactive power. So again, there will be a need for smart grid, flexibility service, storage, and again, very important, lower cost. So what is the business idea about behind V2G? An EV is only driven typically 2 to 3 hours per day, at least for sedans. And that corresponds to about 8 to 12% capacity factors, which is very, very low. And another beautiful thing is that an EV has already been paid for by the EV owner. So the business idea is a little bit like that of Uber and Airbnb. Why not borrow the battery of the grid for energy flexibility services at very low marginal cost? And then the money that we receive, we can pay the EV owner for the rent to lower the total cost of EV ownership and bring down the cost of EVs. Here's some example about an EV battery, and it can support many applications, just like a Swiss Army knife. The main purpose, of course, is to support driving. That's why we buy the vehicle. But it can also be used to power the home. It can be used in emergency power situation. Here in California, we have power outages because of wildfires, and we can use, for example, our school buses to provide community energy power. We can use it as second-by-second frequency regulation. We can use it for peak and off-peak arbitration, so we can actually arbitrate between peak and off-peak energy prices. Here's a picture of a Rivian R1T that's lighting Christmas trees. We can use it for demand response. We can use it for vehicle to load. In 2024, all blowers, leaf blowers in California, new leaf blowers will have to be electrified. And here's shown a Tesla Cybertruck, which is charging an ATV. We can use it for vehicle-to-vehicle power flow, demand charge management to bring down the cost for businesses, and we can also use it to help the distribution grid, for example, with voltage management. Now, so the benefits, summing up the benefits of V2G, it lowers the CO2 emission and reduces city pollution. It moves, at least in the beginning, the pollution away from the city. But of course, the grid power still has to be a bit greener. It lowers the cost, can lower the cost of total ownership of EVs. It will provide massive amount of low-cost energy storage to the grid. And it will enable more renewables, providing flexibility services that will be able to flatten out the curve of renewable energy, being it solar, being it wind. And it can defer and lower the cost of distribution grid upgrades, which is quite important because those millions of EVs in the grid will mainly affect the distribution grid. And the beauty of the whole thing is that the batteries have all been paid for by the EV owners and no cost to the ratepayers. So we can say we enters a virtuous circle where more vehicle to grid will allow more renewables, which again will feed more zero emission vehicles with clean energy. So how can India take advantage of vehicle to X? We can stand on the shoulders of 10 plus years of worldwide V2X project experience. For myself, I've been involved in 13 projects worldwide. So there's a lot of project experience that has been gained. The EVs and the EVSE OEMs have entered the market, and we see that, for example, last week, Volkswagen announced that they are providing on the new MEB platform bidirectional power, and this supply is accelerating. International standards, and we can get that more into that in the panel discussions, are almost ready. They're almost there. There's still some way to go. And interconnection is how do you connect electrical vehicles into the grid is pretty well understood. Both DC and AC grid code support is well understood and supported, but we're still not there. And market models, very important, have been evolving. There's still time to catch up and leapfrog, because the V2X markets are still in the infancies. See, it presents a unique opportunity for India. India is only the beginning of e-mobility, with about 0.5% of their vehicles are actually true EVs. Have a very strong educational system with world-class universities, world-class software, and the competitive automobile industry. This is important, world-class software and competitive automobile industries, because a lot of the value will be in software, and of course there will also be a lot of value in the automobile industry to support V2X. The bidirectional EV flow will reduce the cost of upgrading the distribution grid to support millions of EVs and distributed energy resources. And V2X EVs will become an asset to the grid instead of being a problem. And very important, the world is moving towards vehicle grid integration, vehicle to X, and this will open up export opportunities for Indian companies. So V2X presents a unique opportunity for India to really leapfrog ahead and become a leader in smart EV integration solutions. The challenges, there are many, it's not going to be that easy, is to make V2X really happen. It's so far, it has really not scaled, and it has to be profitable. Otherwise, there will be no market. So V2X will not happen unless the owner wants to participate. So here's a customer-centric view of V2X. The V2X EV owner, for him to participate or for her to participate, it has to be simple, it has to be intuitive, and there has to be benefits. So we need to have inexpensive technology. We need standards, worldwide standards and interoperability, and we need to make it very simple to interconnect, which is not the case today. And then we, very important, need beneficial rate designs. There has to be tariffs that will enable positive business cases for the EVs and EVSE OEMs to participate. So it has to be plug and benefit simple, and for V2X to become a success, it has to be simple, intuitive, and beneficial. So thank you for listening, and now let's turn to action. That was the end of my presentation.
Thank you so much, sir, for such an interesting presentation. Now I would like to invite Professor Zakir for his presentation on V2X implementation in India. Professor Zakir.
Thank you, Ruchi. Can you please confirm if you can see my presentation in the presentation mode?
Yes, sir, we can see it.
Okay. A very, very good evening to all the participants here. To begin with, it will be relatively difficult to cover all the topics and the analysis that we have done under this study in this presentation, which is tailored out in these reports that you just would have catch hold of. And on top of that, we are running a bit late with our schedule, and I do not want to take out time from the panel discussion, interesting panel discussion that we have. So I think I have to be a little faster in my presentation, but I hope I'll be able to summarize the study that we have done and documented a lot of that in these reports that are released in today. This is the aim of the study. We broader aim of the study of this implementation of vehicle to everything in India. Again, from the beginning of the study, the intention was to learn from the experience of different projects, demonstrations that have been done in different parts of the world, as mentioned by Bjoern already, and then learn from them and see how we can actually take it from there in Indian context. And we also were conscious of that economics plays a very critical role after technical actually compatibility. So we also had intention to do detailed techno-economic analysis of these different V2X applications, which have been already mentioned and explained in the previous presentation by Bjoern. And then finally analyze and frame these policy recommendations, regulatory recommendations, technical recommendations for seamless adoption of V2X in India. As you already have seen, we have documented it in 3 reports. So therefore, I would like to skip this part. And these are the broader topics covered in the reports. Review of international these V2X policies, regulations and experiences, particularly in some of the EV-rich countries, which have been doing studies and demonstrations, pilots around this area: Denmark, US, particularly California, Netherlands, UK, Germany, and other few countries. Then we focused on the report covers this gap analysis for V2X adoption in India, looking at regulatory challenges, technical challenges, economic, social, and other organizational administrative challenges in V2X adoption in Indian context. And then we did deep dive in techno-economic analysis of different V2X applications, which included individually V2G, V2H, V2B, V2V, and other V2X applications. And then finally, recommendations and requirements for V2X adoption in India, or enablers of V2X in India. We did a detailed impact analysis, but I would not actually spend too much time on that, because we have done, and several other studies have done impact analysis already in different contexts. So this is done in one of the distribution systems in India from one of the discoms, where we looked at different aspects of EV integration with those distribution feeders, and looked at different forecasts of EV ranging from 0% to 100% EV penetration, looking at the loading. As you can see, peak load increase with dump charging, uncoordinated charging, transformer overloading, depending on what percentage of EVs are being integrated in the system. Even, I mean, to make it simple in understanding, even simple slow charger of 3.3 kilowatt will almost double the load, and peak load, particularly if it is a simple uncoordinated charging. And we looked at the voltage profile that also gets impacted. Loading of the distribution lines, that certainly gets impacted, particularly at higher penetration of EVs, if that corresponding discom is not taking countermeasures to address those impacts that these electric vehicle charging load is going to bring into the distribution system. We looked at single-phase domestic charging as well, in addition to the public charging, and where we actually took deliberately uneven distribution of these EV chargers among the phases, and almost perfect distribution of EV chargers across these 3 phases. So we realized that in the case 2A, where we had uneven distribution of EV chargers, it definitely results in imbalance and other issues in the distribution system, transformer, overloading transformer, heating due to EV load and also unbalanced loading. But we also realized that even if the DISCOM happens to have ideal distribution, equal distribution among three phases, there also is these imbalance that will arise due to the timing of the charging that will be connected to the grid, behavior of the EV user that is connected to that particular phase. So even then, there is going to be unbalance and other related issues, including power quality issues in the system, besides loading of the feeders and loading of the transformers in that particular feeder. Coordinated charging, we tried a little bit here before going into the details of that, where we could actually found that coordinated charging could actually address some of those issues that were there with dumb charging. Then we looked on another case study, that's reactive power support from electric vehicles, which generally is not much thought of, because the main focus is if it comes to the grid support at transmission level, it comes primarily on frequency side. So we looked at the reactive power side, because the reason is the first parameter that we saw getting impacted at the distribution level along with the loading was the voltage profile. So we tried to see, can we use the source of the problem here as a solution of the problem. So we looked at possibilities of utilizing these electric vehicle charging infrastructure to support this distribution system with reactive power. Because technically, EV charging infrastructure can provide reactive power support to the grid, even when EV is not connected to the charger, provided that the charger is having controlled converters, not rectifier, diode-based rectifier. So you can see here the impact on some of the feeders in this distribution system that we did this analysis at. These blue colors show the low voltage profile because of EV integration. And then when we try to take the support from the chargers, public charging stations, particularly not home charging here, we realized that these reactive power support from public charging stations, without impacting its primary job of charging electric vehicles, it could actually address this voltage profile issue. And you can see here the voltage profile with and without reactive power support from charging infrastructure. In addition to that, while you are providing the local reactive power support, it actually results into reduced reactive power draw from the transmission side. And this yearly analysis we can see here, we had month-on-month basis. We considered the Indian Grid Code 2020 as well, and the draft Indian Grid Code 2020, because at this time of this study, it was in the draft stage, which is no more in the draft stage now. But we considered both, and you can see here, depending on the regulations, you could actually have the DISCOM could have the savings of varying volume by having the reactive power support. This is only for the reactive power penalty that they would actually need to actually pay. On top of this reactive power savings that they could have, there is also reduced system losses, because we are now providing reactive power locally in the distribution system, so that reactive current doesn't flow throughout the distribution system. As a result, those losses are not actually getting added to the DISCOM's overall distribution losses. So these are some of the plots, and details are provided in the reports for those who are interested to have detailed understanding of these case studies. So we found two major benefits here because of the local reactive power support. It improves the voltage profile locally and also reduces the penalty that otherwise or the payment that otherwise the grid DISCOM would actually need to pay for the reactive power support drawn from the transmission side, and also reduce the losses in the distribution system. The another case study we took for a food industry, food processing industry, if they could actually put up a captive public charging station within their industry, again, Delhi-based food industry here. And we try to have that this public charging station would actually encourage their employees to adopt electric vehicles. The purpose of this public charging station will be to actually charge the electric vehicles at the chargeable rates, which is going to be this main business. But this public charging station could actually also provide the reactive power support, because this food industry, processing industry, is a poor power factor industry, a 0.65 lagging power factor typically, and they otherwise either have to have their own infrastructure for the reactive power support, or they would have to actually pay the penalty for drawing more reactive power from the grid. And these are some of the figures you can see here in terms of the savings that they could actually have in annual savings on demand charges as per the prices that are in place right now in Delhi. Demand charges and energy charges, you can see here, these are monthly and accordingly, these are the energy charges. So total charge savings for this case study, with the assumption that we made and the prices that we took with that are currently actually in place in Delhi, this is the saving for this particular food industry plant with this public charging station in their premises. Frequency support, we measured the frequency of Indian grid at IIT Bombay campus. You can see here, we analyzed the frequency, and we realized that frequency of the grid is not perfectly around skewed around 50 hertz. It is always mostly little lower than the 50 hertz, particularly if those who are following the power sector closely. After this new DSM regulation, there was some disturbance in the frequency in the grid. And what we realized is that we have to carefully analyze the frequency of the grid and before designing the overall control of frequency support from these charging stations. Because if we assume the frequency to be around 50 hertz and it is not actually, it's offset by some value, then the control actually is not going to actually give us the results that we would like to have from this frequency support from these EV fleets. So you can see here in designing the controller, if we go with the ideal case, then we have to accordingly design the deadband and other parameters of the controller. But in this case, looking at the frequency profile, we modified the overall control of this frequency support from these EVs. Again, with the assumption that EVs are allowed to participate in the frequency support, that regulation is not at the moment in place. So therefore, that assumption was made. And we also looked at the economic analysis as well. These are different scenarios depending on what capacity of the battery the EV user is actually allowing to play with during this frequency support from their electric vehicles. 70% of their allowable, 80%. So actually the usable energy of the battery is 80% from 0.2 to 1, this SOC, or 20% to 100% SOC, or if it is allowing the entire 80% of the battery energy to be used for grid support service. So accordingly, the potential this revenue for each user is actually varying depending on how much they are allowing the battery to be used for the grid support services for the frequency support in this particular case study. Then we also look at the vehicle to home here, how EVs can actually help in V2X and better integration of RE at V2X level. And you can see here some of the forecasters of the EVs for 2021, 25, and 2030. And then we accordingly, considered how much EV energy will be required for these electric vehicles. And then we took different scenarios, whether you have 20%, 40%, 80%, 60%, these penetration levels, and accordingly the PV and wind mix of this renewable energy. These are different case studies that we analyzed. Storage allowed for V2G per EV, so 10% scenario, 20%, 30%, 40%, different scenarios to demonstrate that how much battery storage can be made available from these electric vehicles if there are adequate regulations and viable business model is available in the market, and how they can actually help in integrating these renewable energy integrations in the grid. At the home level, one house level, you can see here potential for V2X in India. So we look at daily operational cost only, not the capital cost. For a very good reason that we do not buy electric vehicle battery for participating in the grid support services. We buy electric vehicle battery for the vehicle, for driving the vehicle. Therefore, the battery is already there. So we are looking only at the operational costs for EV users here. So we found that V2H was actually one of the promising solutions coming out with the assumptions that we made and are mentioned in the report in detail. V1G also we found is actually is better than dumb charging, and with V2H actually it's much more having better operational cost savings for EV user itself. And we took different case studies which are mentioned in the report. Now coming to the final leg of this study and the reports is enabling V2X in India. So we analyze the challenges of V2X in Indian context, regulatory challenges, looking at the grid code regulations, requirements, standards. For bidirectional charging, we will probably talk more about the standards in the panel discussion. Technical discrimination for providing grid support services. For example, V2 electric vehicles should be allowed to participate in the frequency support services in the market the way they are actually allowed at the moment. In some countries, for example, in Denmark, enabling small providers to participate in the electricity market, establishment of adequate tariffs market at DISCOM level, and technical challenges, limited V2X capable sources are there, resources are there, complexity in communication requirements, limited experience with V2G demand response programmers, energy product market, this product related matters, and battery degradation which again is debatable, but still it is one of the factors that EV users would actually look at before participate in the V2G services or V2X service or any other V2X applications. This toxicity in EV charging behavior needs to be accordingly adequately handled. Ancillary service requirements and structure for ancillary service market, DR management expertise, requirement of supporting infrastructure. Economic challenges, societal challenges, organizational challenges are listed here that we actually analyzed it in the report. Again, in the interest of time, a little bit running fast here. Now, what are the already some good points in India for V2X adoption in the country? We have, most of states have time-out data for its customer base, which also includes TOD for EV charging in some of the states. So we could actually make use of that. Electricity market, out of around 196 countries in the world, around 41 countries have operational energy exchanges, and that gives an edge to India here, which could be potentially utilized to bring these electric vehicle V2X applications into the market, particularly V2G. Energy exchange in accordance with electricity regulatory authorities in India also have strong focus on trading the green energy. Most of you would be familiar with green open access and green term market and other initiatives that have been recently brought into the power sector. So we have this smart grid mission, which also can be taken advantage of in this adoption of V2X. And another advantage is we are at the early stage of EV ecosystem. Therefore, we have an opportunity to actually have learning from the experience of these different EV-rich countries and actually take it forward from there. We have some of the international experiences for V2G. Denmark is certainly one of them. There are at the moment actually operational activities happening in V2G space. UK is one of the leading countries, I would say, in V2G activities, V2X activities, different actually services that they are actually exploring. Netherlands is another country. There are other countries also, but again, every country cannot be actually covered here in the interest of time. US is there, California already mentioned it. They are also in this space enabling V2G in India. We actually give this framework here. We divide it into the 3 baskets: technical, regulations and requirements, commercial side, and then policy side intervention. So technical, if we look at the technical side here, grid interconnection regulations, we need adequate grid regulations down the line, so that as we have increased intake of these electric vehicles, we can better handle them, particularly in the context of V2G. We need to actually introduce. CA is already actually has initiated activities around V2G, as you can see through their earlier activities. Through this activity, that needs to be actually further enhanced. Communication related aspects needs to be addressed, which are very important in exploring this V2G or other services from these electric vehicles, be it smart charging, V1G or V2G as well. Protection and safety regulations are also important. So that needs to be extended to the V2G services as well. And G&E also is another aspect. From the commercial side, we have these tariff structure, that's commercial regulations, energy market or electricity market required for them to actually participate, suitable market for service to the distribution network, participation, awareness, adequate remuneration, policies and taxation. We know it is currently having double taxation. If it is V2G, that needs to be addressed, and other actually policy interventions are required beside this these ancillary service markets. What are the hardware requirements for V2G? We again in our study actually divided into different baskets. V2G chargers coming from the charger side. It has been CHAdeMO for a while globally, which is actually enabling V2X bidirectional flow of electricity between a vehicle and the grid. Yes, so but there are issues with the now with the future growth of the CHAdeMO. We again surely will touch upon this aspect during the panel discussion. CCS is there, but is being actually talked about. There are some activities happening in US, but again, it's not out yet fully in the market, global market. So there is this temporary gap created by the lack of these standards and the charging technology for this V2G activity. Now the EVs itself, which is on the demand side, we should have adequate EVs in the for this V2G at the moment. Because of lack of market, not many V2G EVs are actually being provided in the market, and we have none of them in the Indian EV market at the moment. None of the electric vehicles available in the market are compatible with V2G. Globally, there are, of course, but in India, we do not have as of now. Grid and meter requirements, DISCOM, because the first level of integration of electric vehicles is actually distribution system, not transmission system, the way it is in the renewable energy sector primarily. So therefore, DISCOMs need to be ready with the metering and charging management system, handling the data, communication, and related aspects of this new technology that is getting introduced into the distribution system. On the policy side, at the federal level, introduction of V2X as a priority sector within EV ecosystem. V2X requires close cooperation from different actually these stakeholders, given that it is an interdisciplinary. So therefore, there needs to be a coordinating nodal agency which actually looks into these different aspects. V2X also needs to be brought into the subsidy regime that is currently in place or is being actually going to be in place, let us say through FAME 3 scheme. Focus on research and development of the pilots, promotion of these grid management services, local energy management solution. As most of you will be familiar with this, this storage was provided infrastructure status, which needs to be extended to this charging infrastructure, including V2X hardware. At state level, several actually initiatives we are proposing, we are recommending in our report. Please feel free to go through in detail through them in the reports. This example we have specifically brought into here to show that how a policy intervention actually is becoming beneficial in accelerating the technology adoption, in this case V2X technology. So there were 8 projects that were brought in this by UK's National Innovation Agency to look at the innovative V2G business models and feasibility of V2G adoption. These projects have actually resulted into commercial products that are currently being tested in the field, and some are actually going into the market. Several hundred vehicles were brought into this under these different studies, and different V2G services were actually explored through these demonstration projects. As you can see here, list of these projects having different focus in terms of battery and PV into the system, V2G services from buses, and other customer acceptance and business viability of fleets and airports, implementation of virtual power plant, and bundling energy service. So different focus areas of these different V2G demonstrations that has actually resulted into quite a bit activated activities around this technology, V2X adoption. Looking at V2H and vehicle to building in India, again, we have adopted the same framework here. We feel that V2H is easy to be adopted, V2B, particularly if it is in an islanded mode, given the regulations may not allow at this stage V2G through home, V2G through building, but in islanded mode, we are expecting that it is going to be relatively easy. So we see the development of these V2X applications through these different phases. Phase 1, which we already are right now in India. Phase 2, we are starting in that direction, which we need to accelerate that phase 2. And then phase 3, where we are looking at this V2H, V2B, where we may not need the regulations immediately. Regulations do not prohibit us in doing these activities. But V2G is to be followed, V2G limited, and then V2G, in full-fledged mode, which actually looks at the grid moves from the grid connection to grid integration to grid support, this particular technology. I would like to conclude the presentation with I would like to express sorry for this typo. It is V2G field pilot studies by IIT Bombay. There are 2 V2G field pilot studies currently being conducted by IIT Bombay to actually take this study further into field and see what are the challenges and what are the opportunities that this V2G is actually having in Indian context. We are looking at vehicle to home, vehicle to grid, vehicle to vehicle activities, and also RE-based vehicle to grid charging stations through these field pilot studies. Since these are at the moment ongoing studies, we will be at a later stage disseminating experiences and learnings from these studies. So please, those who are interested, feel free to stay connected to these field pilot developments at IIT Bombay. With this, I would like to conclude my presentation and hand it over back to Ruchi. I hope I was able to complete it in at least not too much of a time. Over to you, Ruchi.
Yes, sir. Thank you, sir. Thank you so much for such a much needed details on V2X technology in Indian context. So moving forward, I would like to invite all of you to join us on a panel discussion on V2G technology and its adoption. For the panel discussion, we have Professor Mattia Marinelli from DTU Denmark, Mr. Bjoern Christensen, CEO, Next Dimension USA, Shri Ashok Kumar Rajput from CEA, and Mr. Ramkrishna Singh, Head of EV Charging Operation from Tata Power as our panelist. This panel discussion is moderated by Professor Zakir. Over to you, Professor Zakir.
Thank you, Ruchi. while we wait Mr. Rajput to join us in the panel discussion, I would like to welcome our panelists. Mr. Bjoern, I'll start from him. He has been involved in this study closely that we have been doing here. And special thanks to Bjoern for joining us. You are in the middle of night, probably there, yet your interest in this area brings you on here. Thanks to you for being here. Mr. A.K. Rajput, we have already introduced and all of us know about him. I would also like to introduce Professor Mattia from DTU. Those who are working in V2G space know him very well. He is one of the leading researchers in V2G space, have done several projects at DTU. And then we have Mr. Ramkrishna Singh from Tata Power. He is leading the charging, electric vehicle charging business in India for Tata Power, bringing in actually the industry side of this charging infrastructure. So without taking much time, I would like to start with the first brief point where I would request all the participants, panelists, particularly those who are in this field. I would like to request you to provide your remarks on what do you think are the major challenges in V2G adoption. We have been talking about V2G for a while. What, in your opinion, are the major challenges in V2G adoption? Maybe Bjoern might want to start with.
Yeah, I can start. I had a lot of scars on my body because I've been involved in V2G for the last 13 years. And right now I'm running a consultancy company here in California. And I think we have all had a lot of optimism with V2G when we started out. Well, when we started out, there weren't any cars that could do V2G and there weren't any EVSE that could do it. But then came the catastrophe in Japan and so forth, and we got the Nissan with the Chatemo. Fast forwarding to where we are today, I would say that all the ducks are not in a row yet. There are tests, and as a matter of fact, in California, specifically our school buses, there are 480,000 school buses in the United States, by far the largest fleet. They are running with V2G, but I would say relatively small. There's only about 300 buses that are actually capable of V2G right now, but they are running with DC V2G. Now, the biggest problem seen from California and also from other states is, I would say, the lack of completed international standards, or maybe even higher importance and barrier is the interconnection. How do you interconnect millions of distributed energy resources, here being automobile, into the grid? The grid codes has to be observed. The grid codes are different from country to country, from operator to operator. So I'd say those are two very major, let's say, impediments. And then one very important thing: the technology is too expensive right now. We are doing DC, which is way too expensive. We have to move also to AC, but AC is right now, there's some issues with the support of mobile inverter. So I would say those are the three major, and then of course tariffs. There has to be tariffs and good, so we can make good business models. Otherwise, there's not going to be any market. So that's my take.
Mattia.
Yes. So first off, thanks for inviting me. And I think that both you and Bjoern actually in your presentation sum things up quite clearly. I have very little to add compared to what Bjoern just said, but maybe just to mention that it has been also a little bit of an unfortunate timing, so to speak, in the sense that with the Leaf and the Chatemo, the technology has been ready, but maybe it was too soon because we didn't really have the numbers to scale up. We didn't have the necessary economic framework or the necessary business cases right in place. Now, I'm looking from a European and more specifically from a Danish perspective, the business cases are starting to be quite relevant. more than in the past due to a lot of reasons, as you may know. And but we are, you could say, missing the technology at this point in time due to the phasing out of the CHAdeMO. So we're in a sort of, you could say, in a sort of limbo while things, let's say, all the stars are aligning, but we are still missing some of the technological aspects before we can really go full speed.
Yes, that's very right, Mattia. You brought in another aspect of it, availability of the technology in the market at the moment. Charging technology is one of the issues that is there, which should not have happened. Maybe we'll talk more about it later. Mr. Ramkrishna, you have any comments to make around this, given that you have been out in the field putting up a lot of charging infrastructure around the country?
Right. So thank you, Professor Zakir, for inviting and giving such a detailed presentation also. I'm sure this would be very helpful to the academia and industries to plan the V2G rollout. There are challenges, Mr. Bjoern, and you have very well explained. But from the implementation point of view, while technological challenges can be taken care by the experts, by the R&D institute. So while we talk about India, so we need to understand the Indian customers' mindset, that they might be having a lot of dilemma for going forward, not going forward, because of certain impact on their vehicle, on their warranty issues, also the awareness about this whole technology. So awareness and education is one of the major challenge for the masses who are going to adopt this V2G initially. In person, I am very fan of this V2G technology, and I see this V2G is going to happen and it will change the entire power distribution dynamics. Okay, because you would be having 30, 40, 100 kilowatt of power within your control and command, which can be utilized anywhere, anytime at your command. Once you have the V2G, V2H, V2B in place. So even though it may take some time and there would be some challenges, but I believe this customer education, awareness, policy advocacy, it would be a great challenge while implementing this particular technology.
Thanks, Mr. Ramkrishna. Mr. Rajput, we lost you again in between. You are able to hear us now?
Yes, sir. Yes, sir. I can join now.
We were discussing, what are the challenges in V2G adoption in general. Any comment on that you would like to have?
Basically, the challenge is inertia. And another challenge is the mindset. Next level of the challenge is lack of awareness, how to optimize. And in the public domain, the benefits have not been quantified so far. Of course, this report makes a good effort that what will be the advantages. Again, I'm repeating, which I in my opening remark repeated, this facility is not for the general use. It is for the constrained time when you are, say, thirsty most and the water is not available. You are going to have a coconut water. And there may be similar such and other examples also. It is like that. So there you are not seeing the cost. A water bottle may cost 10, where a coconut water may cost you around 40 rupees, 4 times higher. But the need is served.
Right.
So it is basically what your needs are there, what your priorities are there, and how you are going to shape your path. Say you dress up daily in the daytime. You dress up according to the need, according to the platform on which you are going. So going to the market, only the casual clothes, the casual dressing can do. Going to a party, certain other things will be required. Going to deliver the keynote address as a chief guest, you will need good vehicle, good clothing, and many other preparations. So this is basically for which application, which type of the model and which type of the facility I'm going to use. Certainly it comes when your grid is stressed most and the power has to flow over the long distances right from the source to the consuming end. And if you have even a smaller sources and in the form of the aggregator, and maybe the one model is the swapping also. Swapping will also complement the swapping of the battery system, where the large number of batteries put at a place and they will be fitting into the whatever we conventionally call as the load curve. Because the load curve is the most studied and most discussed part of any power system. So things are not new. It is basically the sources of power generation and the power sinks and where we put in the application and for how long we put in the application. And in the battery, there is a phenomenon known as the rate of discharge also. So you can have through the VMS media or through whatever the source, the IT technologies and these technologies are there. You can control the discharge that this will be discharging at this rate at this particular moment. So that is basically required. And say if some peak is there, some notches are there, and very high peaks are there. Thing is how to control it down. Like the fever rises, beyond 114 degree, 1104 Fahrenheit. We used to have, along with the medicines, the wet cloth strips also. So these are the things which at particular locations and at the critical important locations you will need into the system. Say if it's a rural village or say agriculture farm and like that. Naturally, you are not going to use the vehicle to grid phenomena and the vehicle to grid supply to those loads. Those loads are always less priority load and the deferable load. So it is into our wisdom that where we want to put them use. Say it's a cinema house and the that is full. You are experiencing something wrong, something very poor voltage and all those things. So whatever fleets you have, whatever in the parking the fleet has gone, that can come to the rescue. And naturally for that, a quantified model that you will be paid this much of the incentive if you support for these many hours. Naturally, the metering, as Ramakrishna ji told, and the tariff structure and the safety issues, they will be the good supports and they will be the key players in this particular type of the business. So that is my recipe for this. And I think we have to move in this way. And it depends how the technology benefits. Say if a particular technology or the particular adoption model is going to benefit a lot, it becomes as a trendsetter. So right now it cannot be a trendsetter. That is very much obvious. But we should not lose hope and we should look in that what are the areas and where it could be trendsetter. So if we work with that way, we should not see that it will become a flourishing business overnight. That is not going to happen. It will be a gradual process.
Right.
And again, sir, at the cost of repetition, the proper metering, the proper technology, and which is long lasting also, those are the pillars on which it will work. Thank you, sir. Thank you.
Thank you, Mr. Rajput, for summarizing the challenges and pinpointing to some of the use cases as well, which are very relevant and important. And it's true that with any new technology that's being introduced in the system, it has its growth curve, it has its challenges while it is being actually brought into the mainstream in the system. So I will take a follow-up question from the response of Bjoern. You mentioned it very lightly, this thing, AC V2G and DC V2G. I think it would be in the interest of the audience here. So this AC V2G that is also being now, is actually projected as one of the alternatives which could potentially be the cheaper solution than DC V2G. Can you quickly summarize the challenges that are there with AC V2G, which is not letting it to actually take forward? Because at the moment, if we see in the market, it is primarily DC V2G that is available in the market. So can you briefly summarize, for the benefit of the attendees here, what are the challenges with AC V2G at the moment?
Well, the benefits if we had AC V2G is much lower infrastructure cost. Now there might be more cost in the car, but there's so much integration going on in the power electronics. So I think that we will get down to a very low delta cost in the car, because cars also produce masses. But the issue with V2G using AC is that the inverter now has to go into the electrical vehicle. And the inverter is, just for the people that are not aware of that, is basically converting from DC to AC, and the grid is AC. So if we want to put energy back into the grid, it has to be AC. Now, the grid needs to have some protection when distributed energy resources are being attached, even if they're not distributed. If you have a big wind farm, if there's a frequency falls, you cannot have all the wind turbines cut out. So you have to ride through the frequencies. If there is some voltage issue, or voltages falls or too high, you cannot just drop out immediately. If you drop in again after a pause, you have to do it in a gradual way, and so forth. All that stuff, and there are many more, is called grid codes. And these grid codes, any energy resource that can push energy back into the grid, that is not a load only, needs to fulfill these grid codes. These grid codes are different from country to country, or mostly, in most cases, different. And that means the car has to adopt different grid codes, but the car is not stationary, and it can move around. And how do you handle an inverter that is now moving around? And that does not fit into the interconnection certification regime of the grid operators, but they used to go to a fixed location and then say, okay, so this is the issue with V2X, AC V2G. There is an addendum in the 1511-8-20 that will support AC V2G and also will support full grid codes. Right now, the grid codes in California are supported by IEEE 2030.5, which is a protocol that supports distributed energy resources. So it will come very soon, the support from standards. I expect maybe mid next year, but we still don't have any cars or electrical EVSE out there that can really support it. But I think it will come because of economics.
Thanks, Bjoern. We have also touched upon this aspect in the reports that were released today. My next question is, we already spoke a bit about it. How this V2Gs, we of course have, V1Gs can also help in integrating renewables, but how V2Gs can help in better integration of renewables around the system. Mattia, you have been doing some studies around renewables and EV charging infrastructure, particularly because of in the interest of those varying wind velocities around Denmark. You have been doing some studies around that. Would you like to start with your comments on how V2G can actually help us in better integration of renewables?
Yeah, for sure. If you allow me, I would also like to comment very quickly on the previous point, just to complement the excellent statement that Bjoern made. So it's definitely spot on. And from a technological view and also an economical view, and AC V2G would make so much more sense for everybody. But there are these challenges from a grid code point of view. One way to solve it would be probably if we could try to align much more the grid codes around the world, so that from a certification point of view, it does not become so much problematic to get a car certified for an India grid code or for a European grid code, US, and so forth. But one other aspect that I would like to mention is that, in my view, we have too many acronyms. I mean, we have V2G, V2X, V2B, V2L. That doesn't help to create a good understanding. I mean, if you pick up a car can do one thing: drive forward, drive backward. That's it. That's easy to understand for everybody. If you try to explain to, let's say, the common person what is V2G, V2X, V2L, V2, they will get lost and they say no. Even if technologically you could do it, the user will simply reject that because it's overly complicated and unclear. So I think that should also be put on the table. But let's say, other than that, coming to your question now, for sure, I mean, there are a lot of interesting aspects. If I can break it down in two parts, the first one, how can you help with renewable on a local scale? Already in countries like Denmark, which are not necessarily blessed by a lot of sun, at least not all year round, like at your place, you can already have for several months that an electric vehicle can easily complement a local photovoltaic installation. The key point, of course, which is a clear conflict, is that the car needs to stay at home during daytime. And that, of course, may conflict quite a lot with a regular driving need. But other than that, if you have some flexibility, you know,
the car can be at the, sorry to interrupt, the car can be at the office also parked during the daytime. So that will also serve the purpose.
That's true. And that will help with a photovoltaic if you have it at the office. That's entirely true. Other than that, if you look at the other renewable like wind, like we have a lot in Denmark, here we have a good periodicity, especially in autumn and winter, where we have maybe a couple of days when there is no wind, and then there is a storm coming, and then there is no wind again. And that creates, of course, a lot of variability on a daily or, let's say, every other day, which is perfect in that sense for a vehicle, given the amount of kilowatt hour that you have in the vehicle. So summing it up, the V2G can definitely help on, let's say, short term, like daily, every other day basis to integrate renewable, but don't expect like a seasonal storage approach with the electric vehicle.
Thanks, Mattia, for summarizing your inputs on this particular point. Mr. Rajput, if you are there, we know that we have a lot of renewables in Indian grid, and we would like to integrate them in more secure and stable manner. How do you see, in your opinion, that V2G can actually help us in better integration of renewables? Okay, so while we wait for Mr. Rajput, Mr. Ramkrishna, any comment on this? I think Mr. Rajput is here.
Yes.
Did you hear my question, Mr. Rajput? The question was that we have renewables being rapidly integrated in Indian grid. How do you see that these V2G services can potentially help us in better integration of these renewables in the system, in terms of increased uptake of renewables through, let us say, co-located solar or wind power plants near charging stations, or through green open access, through other means, help increase in these increased uptake of renewables in the system, and help, or possibly help in grid stability through frequency support services or other market services?
In a very simplified form, the answer is we have to think in a wholesome manner. And that wholesome manner is that during the hours, during minutes, and during the seasons, the potential of the RE changes. Similarly, the load behavior changes depending on the weather. Unless these modelings are exercised more and more, and the application of AI tools is there at the Renewable Energy Management Center and whatsoever the distribution load management center or the local control centers are there. So those models which are quite predictable based on the past learning and based on the forecasted data, that help we have to take not only the simplistic operation of the power system in an usual manner. So on those things we have to invest. We have to start thinking and say there will be bidirectional flows into the grid also. We need to strengthen particularly our distribution system and more sophistication in the protective device and the metering systems. Because ultimately what happens is the revenue which any utility or which any participant stakeholder as a stakeholder would like to earn. Technological solutions is the responsibility of the researchers and those who are innovating. Furthermore, one more advancement is that the things comes into the practice once they are installed as a new, they work fine. But over the time, they are not maintained properly. As long as they are in, say, some service contract or annual maintenance contract, the things are still working. But afterwards, we lose track of it. And whatsoever investment, I'm being slightly harsh, whatsoever investment are made, they are not fully utilized and sometimes go as waste. So that should not happen. And wherever the old and deteriorated system, either in the form of the EV or unsafe lines are there, or say unsafe our hanging cables and wires are there, those also need to be corrected because everything affect ultimately the source end also of the system, not only the consumer end, but the burden, excessive burden on the source end also. Yes.
Thanks, Mr. Rajput. Very important that besides technological solutions, we need to have commercial regulatory mechanism in place, how to, for example, account for the metering at a low voltage level when these different services can potentially be exploited or taken from these EVs. Mr. Ramkrishna Singh, any comment from your side on this particular point?
Hi. So yes, I think this RE can complement this V2G very well in terms of its financial viability and also in terms of acceptance by the customers. But with the enablement of government policies, what Mr. Rajput suggested, that until unless we have the policies in place which motivate the customer to go in for the V2G complemented with RE, I think that can be a fantastic game changer in the energy space.
Thanks, Mr. Ramkrishna. Bjoern, you briefly touched upon this point in your slide, one of the slides. Would you like to have a comment on this?
Excuse me, on what?
How V2G can help us in better integration of renewables?
Well, very briefly, if you looked at the dot curve in the middle of the day in California, right now we have a net demand which is not, it's in maybe in the 15 gigawatts, and normal consumption is about 30 gigawatts during a day without renewable. And the maximum capacity of the grid is around 51 gigawatts in California. Now, if you look at the dot curve, and if we go to 2030, maybe even before that, we will go into negative terrain. That means we would have a negative demand in the middle of the day. We need to soak up that energy. Either we need to stop all the PVs like they do some places in Australia right now, in South Australia, which is not a very good solution. That means basically to curtail it, throw it away. Or we need to export it, and that's a problem where we don't know where to export it to. That may be different in other countries like Denmark that has very good export capabilities. How do you soak up the renewables in the middle of the day? If you had workplace charging, and maybe with solar panels mounted on on top, you could soak up a part of that energy. Then when we get to the night or to the evening, from 5 till 9 in the evening, we have this enormous ramp which is a big challenge to the grid. And then also the prices goes up very much. So you could, in theory, discharge not very much, maybe 5 kilowatts, because the typical consumption per hour is 1 to 2 kilowatt or something, maybe a little bit more. So you could actually, with very little energy, you could just cut the very expensive energy and very CO2 expensive energy that you would get from the grid. So those are just two very small examples. And then, of course, behind the meter, there are a lot of other opportunities that if you have solar installed.
Thanks, Bjoern. Very important point that you made here, how V2G can potentially address some of the very specific issues that are with renewables, for example, duck curving, solar, PV integration, and related aspects. I have now another important point where I would request panelists to actually give their opinions, their comments, which we touched upon during the presentation during the course of this event briefly, but we'd like to have a little more discussion on this around standards and protocols of V2G, how this lack of globally accepted and adopted V2G standard is at least temporarily creating dent on the V2G adoption to some extent at the moment. I think Mattia mentioned this a little bit earlier. So I would request Mattia to start with his comments on this particular aspect. Then we'll move on to other panelists.
Yes, yeah, I think that it does play quite a role. I'm not sure I would put it as the main problem or the main showstopper for V2G diffusion worldwide, but definitely not having or having a technology, having a standard in the beginning, which then it's been basically ruled out in several countries, does not help that, because then you need to focus on too many things. How to, let's say, how to converge and make sure that we don't have to do too many different implementations. I think, as discussed in the previous points, let's say a clear business case or a clear set of business cases is definitely useful. A clear set of regulations will definitely help. User awareness and making sure that people understand what the technology is about and what it does, and that's another critical point that maybe we haven't discussed too extensively about battery degradation. It definitely has an impact. It does not have such a big impact and someone might think in the first place, but also depends a lot on what you're using the battery for. So all these aspects needs to be clarified. And in the end, yeah, well, now we know the story with CHAdeMO. You could say it's a little bit of it's putting a kind of a pause for the time being, but I mean, we'll get past through that, and we will continue with other standards, whether it's an AC or DC bidirectional charging.
Yeah. Thanks, Mattia. Bjoern, would you like to put your comments on this particular dimension of the technological? I would not say the technological challenge, but it is there at the moment.
Excuse me, do you want me to address standards or?
Yeah. How do you see the standards playing out? You know, CHAdeMO versus CCS that is playing out there, or lack of, I would say, fully adoptable, globally acceptable standards is actually, at least to some extent, has impacted the adoption of V2G.
Well, standards, as you know, the 11th of March in 2011, we had the big earthquake. And then after that, Nissan and the Mitsubishi actually introduced vehicle-to-grid, V2G in the cars. And they worked together with grid operators. And that's why they came up with a very good standard, as a matter of fact, that's really working and taking into consideration a lot And we've been using that in a number of trials and even deployment with Nissan Leafs and Nissan ENV200 cars and Mitsubishi. So unfortunately, in the Western world, we are abandoning CHAdeMO. I think that's clear to say. So we are moving towards 15118-20, I think it's fair to say. And those standards, as I mentioned, are already ready now. There's an addendum that will cover AC with the grid codes, which should be hopefully ready by mid next year. So that's an EV to EVSE interface, both for AC and DC, but we're not there yet. It's still, you know, if you go out and look at the marketplace, there aren't any implementation. There are tons of trials and things like that and so forth. And now, if you look at the next interface, which is from the EVSE to the back end, you know, there's a lot of implementation of OCPP and most in 1.6. We're moving now to 2.0.1, and then interworking between the EVSE and the EV protocol and the protocol to the back end. So I think we're on a very good track there, but we're still not there. And then, of course, I'm not even going to go into the roaming. Now, let's just move to the most primitive thing, which is a plug. And it has not been helped by some American company that has a factory very close to where I live with the introduction of the NACS standards. They call it a standard, and it will be a US standard because, as usual, we here in America, we can't wait until, you know, international standards are there. We have to make our own standards. So I think there's still some confusion there, and that has not helped, together with what Mattia is saying with the education. So if you really want to confuse consumers, then just add what Tesla just have done. But they have so much market power and they will get through. One thing that I think is still not really covered is standards, plug standards for medium to heavy duty vehicles where you need more power. And there is the MCS standards coming out, but there is also AC standards in the United States called SAE 3068, where with three-phase AC, you can go up to 130 kilowatt at a very, very low cost. And so that's out there playing. And then if you look at the three-wheelers and the two-wheelers and the boats and whatever it is, I think we have not seen the end of this. So it's something just like the internet. Shall we use Apple Talk, or we go Token Ring, or whatever it is, and eventually we get to Google and we get to Airbnb. So that's my take of standard. It's a process, and it will take some time before we have interoperability, and we'll just have to deal with pockets where we have proprietary solutions close to standards, and eventually, just like we did in the mobile industry, we will eventually come up with standards where we can really scale.
Okay, thanks, Bjoern. So I think we have already, you know, overshoot the time that we had, but it had been very interesting discussion, and I believe that it would have been very informative and useful to the audience as well. And I think in the interest of time, I probably have to cut short here our panel discussion, and let us not hold back the audience for too much time. So I would like to thank all the panelists for your valuable time, for joining us and giving very, very important and useful inputs on this very important topic, emerging area. A lot of focus is being put around this, and a lot of new information has come out of this panel discussion, and I think very useful information. So I would like to thank Mr. A.K. Rajput for his time and valuable inputs, Mr. Bjoern, Mr. Ramkrishna Singh, Professor Mattia, for bringing in the international insights into this particular topic. Thank you so much for joining us in this panel discussion. Thank you. Over to you, Ruchi.
Thank you very much, Professor Zakir and the panelists. It was a quite enriching experience and quite very good learning for all of us. Thank you.
Nice meeting you.
Nice meeting, pleasure.
Thank you, sir. Thank you, everyone.
Thank you. Thank you very much.
Let us take advantage of this reports, whatsoever the wisdom has been poured into this report. We take it as a foundation and take it still further, sir.
Forward. Thank you so much.
Yeah. Really.
Over to you, Ruchi.
Thank you, everyone. This panel discussion has definitely defined a new problem statements and put up an interlinkage between various sectors in the adoption of V2G technology. Thank you to all the panelists for bringing such an interesting discussion before us. With this, we have come to the end of this event. Therefore, I would like to go ahead with the vote of thanks. First and the foremost, I would like to thank our esteemed guest, Shri Ashok Kumar Rajput, Mr. Ramkrishna Singh, Mr. Bjoern Christensen, Professor Mattia, Professor Suneet Singh, and Professor Zakir for taking out time from their busy schedule for this event. I would also like to thank our stakeholders, Mobility House, IoTeca, NL Group, Fermenta Energy, Charin, CERC, Dr. Indradeep Mitra, Ms. Sahana, Tata Power, and BYPL, who have provided their valuable inputs from time to time to help us structure this report in its present form. Also, CEA and the Grid Integration Lab IIT Bombay team for the engagement during the study, during the report preparation, and the event organization. Lastly, I would like to thank all the participants for joining us in the launch of this report and making this event a remarkable one. Thank you, everyone, and have a great evening.